Hi everyone, welcome to McKinney Learn series on limits and continuity. In this series, we are going to do a deep dive into this topic with regards to how it applies content-wise to AP Calculus, but not only that, also understanding how to expect to see questions from this topic come in exams. I think it's really important so you understand the translation from what you learn in class to how it appears in the exams, but to also keep in mind the traps to avoid and things to remember more. So without further ado, I'm going to help you understand the foundation of what a limit is, and then we'll go from there. So let's try to understand what a limit is. And here we're going to use a question to try and build that foundation. Pause or take a moment to read this question and really understand what it's saying. I'm going to underline the word heading. It's a key word here. So, what is the y value a function is heading towards even if it never gets there? I underlined the word heading towards for a reason. It's the key concept here when we're talking about limits. It's not about the destination, it's about the journey. How is the function behaving as we are getting towards that value, not at that value? So the key thing when you're thinking about limits, you'll always think that it's about the journey, not the destination. So the y value of function is heading towards, even if it never gets there, that's a limit. Let's try to understand this visually. So assume we have person A on the left-hand side and a wall on the right-hand side. Person A is following steps that are moving towards the wall. In this case, if they ask you about the limit, it's not about whether person A hits the wall or gets really close to it. It's just asking you, where is person A heading? Person A is heading towards the wall. We don't need information about whether person A is going to get to the wall and stop, is going to get to the wall and keep going. What matters now is that person A is following steps that are closely leading him or her towards the wall. And that's what a limit is about. If we're thinking about it mathematically, this is how you'll see limits portrayed in your textbooks, in your exams, in all situations. So limit as x approaches 2 of f of x is 5. I'll repeat that slowly, especially if you've not seen this before. This reads as the limit as x approaches 2 of f of x equals 5. So as f of x gets closer and closer to 2, the y values get closer and closer to 5. And that's really important because this is one big trap that AP Calc students fall into. This is not the same thing as f of 2 equals 5. Absolutely not the same thing. Do not fall into this trap. So if you need to write this down and memorize how you interpret what a limit is so you don't fall into this trap, do that. This reads as the limit as x approaches 2 of f of x equals 5. So that's the limit as x approaches 2 of f of x equals 5. So as x gets closer and closer to 2, the y values of this function get closer and closer to 5. I hope that makes sense. Next, we are going to go deep into one-sided limits before we get into examples.